Good evening, ladies and gentlemen, and welcome to this evening's live presentation on Designing with Nature by Hugh Dutton. I am Peter Terrell. I'm your chair for today, and I'm also chairman of the Institution of Structural Engineers. So it's my very great pleasure to introduce Hugh Dutton. He is the owner and chairman of HDA, Hugh Dutton Associates, and his topic for this evening is designing with nature. Hugh was born in Oxfordshire in 1957 and was taken to Jamaica by his parents at the age of 3, where he lived on a banana plantation which his father owned and ran. He was sent to school in Canada aged 13, where, according to legend, he was suspended for some time, and in the middle of the Canadian winter was sent back to Jamaica, which he obviously did not enjoy. However, his parents managed to reinstate him in school, and following advice from his mother's great friend, he went to study architecture at the University of Waterloo, and he studied architecture and environmental studies, and came out of that at the age of 21 with a bachelor's degree. While he was there, he met Mark Fisher, a famous rock set designer, who designed for Pink Floyd and many, many others, who I'm sure many of you know. And Mark advised him to go to the AA in London, to the Architecture Association in London, where as he was studying, he shared space with Ian Ritchie, and who asked him to join him. And so, after his degree, he went to Paris, where he joined RFR, Rice, Francis, and Ritchie. He spent 13 years with Peter Rice at RFR, muddling the boundaries between architecture and engineering, is how Peter put it, and working towards the goal of pure holistic design. Hugh formed HDA in Paris in 1995 after the tragic death of Peter, and as you will discover, has continued to explore, develop, and perfect the relationship between architecture, engineering, and the forces of the natural world, combining holistic design with a rigorous attention to beautiful detailing. Hugh is an extraordinary architect, very, very talented, and is one of the best engineers that I have ever met, despite not having an engineering qualification. And despite and perhaps because of. Anyway, I would now like to hand over to Hugh for his presentation, and I hope you all enjoy it immediately.
Thank you, Peter. Thank you, Peter, very much for that very kind introduction. It is an honor to be invited to speak at the Institute of Structural Engineers. And on particularly at this time, which is the 27th of October, knowing that Peter Rice passed away on the 25th of October in '92. So it's really quite a touching moment for me, and I'll be sharing with you some work I did with Peter, and then some of my own work. And I concentrate on 4 projects to explain some of the ideas about what I've learned and my approach to design, which I have to say, back to Peter Rice, was it was so lucky to be trained by him when I arrived in Paris to do the La Villette Science Museum as a part of the RFR group with Ian Ritchie and Martin Francis. I was 24 years old. I just came out of the AA, and I had decided that as a student at the AA, it was a time when architecture was was asking a lot of questions to itself. The modern movement had been considered by many as a failure, and there were so many doubts about where architecture should go. And it was interesting to be invited to go to Paris, where we had the grand projects of Mitterrand, where the city was a buzz. It was so exciting. There was the thrill and the joy of giving architecture another chance. So it was very lucky for me to end up at RFR. I personally, as a student, I wanted to learn how to build. This is why I went to work with Peter. And I felt that what a wonderful opportunity to be able to work on this museum. Peter actually, in his book, An Engineer Imagines, he called RFR a laboratory for testing the fusion between architecture and engineering. I was an architect. There was Henry Bardsley, also an engineer. Peter used to call us me the optimist, Henry the pessimist. He'd bounce questions off me off him, and it was a very fruitful time. We ended up redefining the use of glass in facades using structural glass, and Peter gave me the honor of writing the book Structural Glass with him. And you can see these images of the patents that we took out as RFR for developing this new suspended structural glass. For me, my role was drawing, and drawing is really, really important. And for me, it's the whole process. It's part of the process throughout all my career and my life. It's been drawing that's so important. I did these drawings of the pieces from La Villette by hand at the time. We didn't have computers. We didn't have AutoCAD to draw them for us or to correct them. If you made a mistake, you had to start again. And so this drawing, I think I did maybe 5 or 6 times. But it was interesting. The context for the La Villette was exactly as Peter had intended, a real laboratory of a mixture of professions. We consulted people with Martin Francis and Ian Ritchie's incentive to go and visit Le Bourget Air Show, to visit glass factories, to visit boat manufacturers who made cables. And so I was sort of brought up in this technology of boat bits, which reminded me of my own background of sailing in Jamaica at the time with my father. And so I felt very close to it. And I was learning. I was very, very, very lucky. After La Villette, I went through a period where I spent a year sort of traveling between London and Paris. I think it was I had a girlfriend, French girlfriend at the time, which is why I ended up staying here. But I used to share my time between Paris and London, and it allowed me. I went to work with Foster on the Stansted Airport, and I did a lot of the details of the tree structure, a lot of work on the facades, as well as reconnecting with Zaha Hadid and Bernard Schumi, who were teachers at the AA when I was there. We did a competition, the Kurfürstendamm competition with Zaha, who also sadly, as you know, passed away not so long ago. And with Bernard, I ended up working quite a lot on his galleries for the La Villette Park. And so this was flitting back and forth. And then Peter said, well, and I decided to get married to my girlfriend, so I decided to come back to Paris and work with Peter. And it was during that year in London, actually, that Peter's office was at Fitzroy Square. I was working in Foster's. And in the evenings, we'd just go and chat and talk about the book that he wanted me to write with him on structural glass, but also just on what we could do in architecture, what our approach would be as designers, and mixing architecture, mixing structure, and designing holistic pieces. So he invited me to come back, and we the first projects we were doing with the nuages, as they call them, the cloud structure in the Tête Défense. But then following that, the pyramids, And I won't go through all of the work we did at RFR at the time, but it's quite remarkable work. I'm sure many of you know it. But it's, again, it's exactly that. It was pieces of value-added pieces for designs where there's a fusion of architecture and engineering. The inverted pyramid by Pei at the Louvre was one of the key pieces, and I think one of the most remarkable pieces of how natural light it transforms this underground space. It's absolutely a brilliant piece of work, and I've always admired it. The way the sloping glass reflects the sky down into the corridors on either side. The assemblies are very minimal. And this was a project actually that Peter himself was very, very much, if there's one of the projects I really think which was entirely Peter, and Peter, his thinking, was this one. So many times he sketched this idea of the tensegrity, making a tensegrity sort of net of cables that suspended the perfect planes of the four sides of glass that are hung down. There's no structure except for this tensegrity mesh that maintains the plane of glass in its inner surface. And I've found this, and I use this example often to students. The difference for me, if you look closely, the difference between the right way up pyramid, the Grand Pyramid, and the inverted pyramid, it shows two very different approaches to design and engineering, which for me reflect quite well the approach that Peter Rice had and that we were taught at RFR. So the Grand Pyramid, it's a layered design. It's quite clear. There's a steel structure, the tubes, with the bracing that stabilize it. That was the engineer's job. That was Nicol from Montreal who did the engineering. And then Pei had his team in New York do the facade design. I think his name was Mike Flynn. I'm not entirely sure, but they brought in the most advanced system of glazing at the time, structural glazing. So it was right at the beginning when glass was bonded to an aluminium structure. So you have the tube, which is about 40 millimeters or 60, I forget, but diameter. You have some adjustment patches because you're supposed to make sure that the structure has got to adjust to make sure that when the glazing comes on, it fits. Two distinct disciplines, two distinct responsibilities, which creates a global design that, in fact, the glazing system ends up being bigger than the tube itself. The approach that Peter had was saying using the glass structurally and using tensile is slight cheating because it's in upside down pyramid. The inverted pyramid doesn't have wind loads on it. But the principles are similar. We could have done the inverted pyramid the other way up. But it shows quite clearly how, in a totally holistic design, considering the glass structurally, every single little piece of connection, of bolt, of fixing, is all integral into the design. Design as one holistic piece. So it's a good example for me of the difference of this approach to holistic design that Peter taught me. And then since that at RFR, we carried on doing this, the work using structural glass. And this, and I can say it's quite remarkable today, this facade. It's 24 meters high, 16 meters wide, one curtain of suspended glass, each one suspended from above, braced only with cables. And I just have to say, I'm showing it today because it's very, very sad. This building, this facade was pulled down recently by fresh architects to redo the 50 Avenue Montaigne, and nothing was saved. It wasn't. We tried to get it with the client, who was the client representative at the time. We tried to get people interested in listing it or retaining it, but sadly, the only memory we have of this project is these pictures, and it's very, very sad. The last project I worked on with Peter was the cathedral in Lille. When Peter was ill, he fell ill in '91, and he decided to stay in London and work from London. And I would travel over, as myself and the other team members of the team at RFR would travel over to work with Peter at his home. And this was a project that really got his attention and his full interest, as he was also writing his book at the same time in Engineering Imagines. And it was a very spiritual project for him. It allowed him to get closer to the church, and again, it was another remarkable opportunity for me. At the time, he was also working on Seville World's Fair in '92, the exhibition, of Seville, using that remarkable project using stone with David Mackey and Arabs who developed that design. So this was a French application of some of the ideas that were going on at the time. And the idea was to create in an existing cathedral this window that is in suspended stone, fitted into the end of the cathedral. So now in Paris, after RFR and after Peter's untimely death, I decided to start my own practice in Paris, in Rue Pequet. And this is a picture of our studio. It's right next to the Pompidou Center, which is quite sort of significant for me in the heart of Paris. We're very lucky to have a skylight, and there are 15 of us, 15 people who are keen, creative, inquisitive, engineers and architects, a lot of students, very young people, and a very motivated team. And we're working on projects in Paris, but very largely a lot in China, a lot in Hong Kong. And I'll just go through, not to keep you too late. I'll just show you a couple of our projects that we've done here at HDA here in Paris. I worked a lot with Bernard Schumi. We did share the space at the beginning with Bernard Schumi, and one of the projects he asked me to work on with him was another way of looking at glass. It was for the Acropolis Museum in Athens, where the museum that Bernard won the competition for was to house the Elgin marbles. The Greeks and Bernard and myself felt that they should be in Athens. So the idea was the museum, the Parthenon Museum, is exactly the same proportion as the Parthenon itself, raised up, elevated on top of the museum, so it gets the full protection, and you get the view of Athens. You can be in Athens with the same orientation, the same light, and so symbolically, it's quite a strong idea. And so here we use glass very minimally. I used 2 skins of glass to create a sort of a thermal chimney, so that the heat of Athens, because it's not only a very rich cultural context, but it's also that the climatic context of the heat of Athens was a real issue. How you create a glass box in Athens. So we created a double skin with a sort of a chimney effect between the 2 skins, but only for the upper pieces of glass. The lower piece of glass was just a single piece with nothing, no framing, just eye level height, so you could get a clear view of Athens, and the hot air goes up. And I have to say, it does work. So it's a facade design, looking to nature, looking to understand the climate and the particularities of the climate of Athens. Another one with Odile Deck here in Paris. We helped her do this very small little restaurant in the Opera building, at this time using curved glass. So instead of using mullions, we curved the glass. This process is used quite a lot. This is one of the very early ones, where just by using finite modeling, we can simulate the structural performance of the glass without mullions. So you get a mullion-free rippled glass where the ripples follow the forms of the arches of the initial Garnier portique. And then some bridges. One of the things, Peter loved doing bridges. He said, he kept saying to me, you know, I'd really like to do more footbridges. Because he said that footbridges are something where you can't hide the structure. The structure is, you know, obligedly, you know, part of the architecture. You're designing the architecture with structural components. So every piece has to function as well as be part of an aesthetic composition. And this actual design was something that I'd actually talked about with Peter. He did a project for a bridge here in Paris some time back and had this idea of using like a bicycle wheel effect to stabilize the arch. So that the arch is stabilized geometrically by the same cables that it's using to suspend the deck from. And so it was fun. The project won the competition for the Olympic Games in the Winter Olympic Games in Turin in 2006. And it's become a symbol for the city. Another one with Bernard Chaumet again. This is in La Roche-sur-Yon, a railway bridge over the railway tracks of the SNCF. The line was upgraded to take TGV trains, and the bridge over the railways has to be a mesh, covered mesh or with mesh sort of protective panels to stop people throwing things on the tracks, or to make sure that the safety of people and the trains is maintained. So we decided to do the bridge as a mesh itself, and then enjoying the idea that a mesh can also, if you look at the mesh, how it is working structurally. So we designed a tube, looked at how the forces would go in it, and then adapted the structure, the shape of the structure, to follow the forces that are in it. So it's just a simple tube of a simple railway track in a small town in France. We're just enjoying the structure, the structural forces, the design, the way it goes together is expressed in the design and becomes an interest in itself. Another project that we've completed fairly recently is in the Louvre itself again. I was very honored to be able to come back to work in the Louvre after working on the pyramids, particularly the upside down pyramid. Peter Rice also helped on the Cour des Finances, the skylights, Marly, and the other courtyards, he worked on with Ian Ritchie. And so this final courtyard here, it's the last piece of the Louvre. I was asked by architects Rudy Ricciotti and Mario Bellini to help them on the design, the technical design of the Art des Islam department exhibition space. It's the last part of the Louvre to be converted in the Grand Louvre project. And Rudy and Mario's idea was to have a very minimal wavy surface, evocative of sand dunes, of a flying carpet, but at the same time, though it's quite bold and very modern inside the Louvre, it's very appropriate. And the scale of it, we decided not to have glass, visible glass, but we wanted obviously the light. So the covering is that the Louvre is covered by some meshes which filter the light. So these are some views inside. Some beautiful photographs by Arietta Atali show the idea of the soft light. And here we wanted the structure to play a very minimal role. It's much more about just filtering light. And this concept sketch that I did shows how we contributed to the design with of Rudy and Mario by making the wave look very thin on the edge, so that the structure tapers to the edge to a point, but it's deep only where you need it, where the maximum bending moments are. So here, integrating the structural thinking into the architectural design, trying to get the feeling of a thin carpet flying, but in using optimum amount of steel and getting the impression of lightness. So, and here's some other pictures. This shows the mesh on the top that we use to hide the glass, to filter the daylight, to limit the amount of direct sun. Obviously, you cannot have direct sun on works of art, but we still want to have the light to be able to see the artwork. There's the cleaning process, and then some other views inside. And we played with this idea of inclining the columns. We could have done them straight, but we suggested to Rudy that, hey, it'd be more fun if they were inclined, like the poles in the Bedouin tent. And it also gives this idea of it reinforces the idea of the roof floating and being a lightweight object. Then another footbridge that I've just completed in Sanya in China. This one I worked on with a friend engineer, Pierluigi Bucci, and a Chinese construction company, the same company that built the bridge between Macau and Zhuhai and Hong Kong. Massive company. And the client just said, we just got to build this bridge. So it happened in an incredibly short period of time. In 1 year, the whole thing was completed, but very well. And we've all been taught to be cautious about some of the designs in China, but this one, I have to say, that was just remarkable. The quality of the construction is quite remarkable. It's a sky ring. It's in the Sanya is the southernmost part of China. There's a long beach and lots of hotels, but there's two shopping developments, one on the island and another one just to the right. And the bridge was to create an iconic connection between these two shopping retail developments. And we won the competition with the idea of creating a sky ring where people could go up on a lift to this platform. I was obviously inspired by the project in Brighton, that remarkable disc that's up there, and I think that here you can get a view of the sea from the top. So on to the four projects I wanted to show you, to talk to you about today. The first is Pylons, electricity pylons. We had the pleasure of winning two competitions, one in Italy and one in France. And I just have to say that I think that these competitions came in the context of a dialogue on electricity pylons. In the UK, there was the competition for the UK National Grid that Eric Bilstrup won, and that was inspired, I think, to a degree by other competitions in Iceland, where these pylons became these figures, these sculptures, holding the cables as they go across the landscape. Those weren't built, but the ones in England, Eric Bilstrup ones were. And it's interesting, in my sort of reading and references and things, I found this poster of Francois Mitterrand, who it just shows how times have changed, how our attitude to the nature has changed. He uses to try and get elected a picture of a pylon and a smoking chimney in the background. And I think so our approach has changed today. The pylons dominate the landscape. I used to call them industrial soldiers marching across the landscape. They're insensitive. They're very practical. They're very functional. They're very economical. But they are hated, and people don't like the electricity pylons. So the two competitions we did were, the attempt was to try and improve the impact of the electricity pylons, the transport of electricity in the landscape. So we inspired, this is the Terna competition in Italy that we won. We literally just took a sort of a leaf-shaped pylon, changing the shape of the pylon. We're very naive, not knowing how the electricity pylons were suspended and how the cables worked. We just thought it'd be nice to use the idea of tensegrity and fix the cables to a network of other cables, so that the only image you saw in silhouette was this very delicate leaf-shaped object. And I was happy to say we won it. And the same friend, engineer Pierluigi Bucci, attacked the project by building a computer model of the whole line, including the pylons and the cables, in looking at them in different cases. But when we went to talk to Turner, they said, no, we have a catalog of, we have a table of, where the suspension pylons are that take the gravity loads, and where the tension pylons are that take also the tension loads. But this approach was completely foreign to them. We won the competition. We tested it. We broke the rig, not the pylon, when we did the testing, and so it was successful. And there's a line on somewhere between Milan and Rome on the highway. You can see our pylons. They are here in the background. The idea was also in Italy. You get this beautiful light, and the triangular sections of the profiles pick up the light beautifully. So it's about, there was the symbolism in the design, sort of reminding ourselves of nature, and sort of what we can, how the design can be inspired by nature. Then we got invited to do a second competition after the one in Italy for a line for the RTE and between sort of Lille and Valenciennes. This is the landscape there. It's very flat, punctuated by church steeples. And so we had a different approach in this project. The client wanted something specifically, a specific line, not something generic that you could use everywhere, just for one line, one design. And so with our experience from Turner, we thought, looked at, and we'll try to think about how the lines could work. So these diagrams show the traditional approach, where on the left you have what you call a tension pylon, the A type, which is one that's capable of taking the forces in the conductors. You can tell them because of the conductors are in the line of the insulators follow the line, the tension line of the conductors. And then you have suspension pylons between them that only take gravity load. So this means then that the lines largely go across the landscape in a zigzag pattern between the tension and with the several suspensions, and then a tension to change direction. So that means that they have a sort of a zigzag path through the landscape. And we found that with the one we'd used for Turner, using the tension line, sharing, instead of they're all tension pylons, they can all take conductor tension, but they share them between them. And when you look at the whole line together, that means you're not limited to putting them in a zigzag pattern. You can make them in a curve, so that you can, and generally want to put electricity pylons along the lines of transport corridors, whether highways or train lines, so that and also that they follow the topography of the landscape. So the fluidity of this new line approach was something that interested RTE, and they liked very much the design. But in fact, with the process of the selection, they were very bold in their approach to the design RTE. The competition was not decided by RTE. It was decided by a local group of the participative consultation with all of the local interest groups in the area between Lille and Valenciennes. So we had to go and present the design in a sort of a town hall in the middle of the place where the line was going to go through, and present it to the farmers committee, the hunters, the people who are the local residents, and it was very, very argumentative. Obviously, as nice as you want to make the pylon, people still had a really hard time accepting this idea of having the pylons. But it was a very interesting process, and it was for me very revealing, because it meant sharing the idea that we can make things better if we design them carefully. So we put a lot of attention into the little maintenance platforms, how that they reflect the light, how all the connections were made to be as minimal as possible, and how just the idea of a pylon, it's a very tall pylon, it's very bold, and it's proud to be tall. We're not trying to pretend it's not there. It's there. We need electricity. We just want to do them designed and try and make them beautiful objects to make them more acceptable. So it's now being built, and they're going up on the line, and you can see that the way they follow the topography, they follow the landscape. And here's the last slide of them tensioning up. This is really quite a. You can get the feeling of how much tension and force is going through those cables. So changing subject slightly. This next project I wanted to talk to you about in designing with nature is in Miami. It happens that for several years I've been working with Swire Properties in Hong Kong. For about 15, 20 years. I've developed a very good working relationship with Swire. I've done many projects with them in Hong Kong and mainland China, where, curiously, very much about, sort of in the similar way, the conversations we'd had with Peter about us doing parts of the building, doing just the pyramid in the Louvre, or doing just the greenhouses at La Villette, doing pieces of buildings, but doing them as part sculpture, part architecture, part sort of key value-added piece. And we'd have conversations with the chairman Keith Kerr of Swire at the time of, he was going to build this big tower in Hong Kong, and I said, well, spend all the money on the lobby. People come to the lobby, they see the lobby, that's where they touch it, and just you can be more economical with the facade. If we spend, and it's the same conversations I'd had with Peter, but here it was with the developer, and this culture, this idea went, and I've done about 10 projects with Swire doing a similar thing. So this time they've just we're developing this massive property in Miami, Architectonica, with the architects Bernardo Forbrescia, with whom I'd done another project in Guangzhou. So we're all quite happy working together. Where they asked me to create what's called the climate ribbon, which is an open street connecting this commercial shopping development together. You have two big apartment towers, a hotel, the East Hotel, two small office buildings on a big block of retail that spans over several Miami streets. So they couldn't air condition it. They couldn't close in the volumes over the streets anyway. So they decided to say, okay, we're going to make an open street in Miami, but what we need to do is to make it a sort of a pedestrian street that's comfortable. So Steve Owens, the president of Swire in Miami, asked me to do the climate ribbon. And this brought me home. These are some fun pictures of my childhood. Peter mentioned I grew up in Jamaica. There's me, age 8, and there's me again in the same place 40 plus years later, 50 odd years later. I grew up in this house with breezes from the houses are built on top of the island of the hills in Jamaica. Catch the breeze, shade. It's all about shade and breeze. So this is what design was about. This is what living, making life comfortable in Jamaica was about. And I went back to the house a few years ago, and it's gone. Nature's taken over. So nature's won that battle. But it was very much a part of me. So coming back to this context was very, very, very sort of strong and for me. This was my first house I did as a student, using wood, and there was no glass. Interesting, ended up being something kind of known for using a bit of glass. But all the windows were just louvres, wattle and daub, mosquito screen, naturally ventilated, no air conditioning. So doing the project in Miami was similar thing, but obviously on a different scale, but with the benefit of the engineering and the technology that we have today. And I think it's quite interesting to take those simple intent of using nature's forces and mixing it, bonding it together with the technology is a way forward. And I think can for me, this project in mind is very, very symbolic and very powerful statement about what we can do as designers, putting together our forces of just common sense, attention to nature, to her forces, to her forms, with what we know about engineering and computers and the technologies we have today. This project, we did parametric modeling in the studio. For the sun, all of the blades, their shapes are determined exactly by the orientation of the sun. We wanted to have views of the buildings and of the Miami sky, have a maximum daylight, but indirect. The light is always, so all these blades are designed to, in function of the buildings in the context of the development. They're all inclined very slightly to optimize getting shade only. And then views where we don't get, where we can see through. And then the other thing we did was to capture the breeze. So this sketch here, it shows the development. We have this street, the Southeast 8th Street, which goes down to the sea. Thanks to my youth in the Caribbean, I know that you have a trade wind from the southeast all the time, and particularly in the hot seasons when it's warm. So you get the breeze coming up that Southeast 8th Street. We wanted to capture this breeze and funnel it through the whole development, but at the same time shade it from the sun. So the east-west blades on this portion protect from the sun from the south. The hotel here protects this band from direct sun in the midday, but the blades, if they're running north-south, they protect from the easterly sun. So this idea, a bit of common sense, and then mixing that with the science, we did these desktop simulations of how the wind would behave. We talked with RWDI, and RWDI sort of confirmed the hypothesis we'd had, advised us that we need scoops to catch the breeze, spoilers to help it out. As this diagram shows, you could see at the tail end of the breeze where it's red, that's a spoiler which lifts it up, creates a negative pressure, drawing the air through and making sure that you get nice breeze flow through the development. We tested that in models in the RWDA lab, piece of cardboard to help us get an idea. So there's a bit of empirical design mixed with the science. Then they did the simulations of the comfort of the people. The red dots are people's this is a simulation of the summer comfort that's based on statistical data that they've had done from surveys of people in different conditions that they've built up. And so we could prove that, yes, we can create a microclimate in the development that's going to improve the conditions. And it does work, I have to say. It's got a lot of success, and I had a very, very nice article in the Financial Times about it. It's been a success, this project. As an architectural statement, as a statement about, listen, let's be careful about nature, a design that's obviously to do with light, with wind, with flowing, that inspires people to respect nature and to also to make the space a nicer place to be. This is the same photograph taken the same place at different times of the day. It's just the way the light moves. It looks as though the roof is actually moving. It becomes a cloud in a way. So, and then some other views. So it's become an icon for Swire, for their projects, and also as the developer, for them to be able to say, this is sustainable design. We care about sustainable design. And it's part of our DNA. Swire is very, very concerned about sustainable development, and this is a flagship for them. And it survived the hurricane of Irma, which was a big test for us all, quite frightening when I saw the hurricane approaching. But we're designed to kind of filter nice breezes through, but when the big breeze comes like this, it's a whole different story. But this, again, it was RWDI, did tests, wind tunnel tests, and the American engineers, MKA, together with Gartner, the constructing the builder from Germany, all pulled their forces together to make the design able to withstand the hurricane. Just as a small little piece here, following the design, I went back to Jamaica. A friend of mine asked to help to work together with him designing the Parliament. Sadly, we lost the competition, but just as a little sort of a little an aside, we made this design of these shells in a park in Kingston, based on the similar ideas to Miami, where we catch breeze, create a chimney, natural chimney that allows natural ventilation of the building. We are obviously inspired by Felix Candela's beautiful shells. We felt that concrete was very appropriate for Jamaica. And anyway, very sad, we lost. But I still like very much the design. We could be entirely naturally ventilated and cooled, as just with the natural breezes from Kingston Harbour. Then back in Paris, this last sort of 2 years, I've been working on this monument for the Hôtel de la Marine. If you know the Place de la Concorde, there's two identical buildings designed by the architect Gabriel at the end of the 18th century for the king. And sadly, this is where they were executed in the Place. But the building housed the navy. That's why it's called Hôtel de la Marine. It's not a hotel. It's the French term for a grand building, and it was basically the grand building that houses the marine. The opposite one on the west side of the square is a hotel. It's the Hotel Crillon, and the automobile club is also there. But this one was changing the function from being the Navy headquarters and offices for several hundred years to become a public space where it would come back closer to its original use, which was to be a garde-meuble du roi. It sounds like the king's furniture storage, but it's actually it's where the royal furniture would be put on show, as in a similar way that furniture is shown in an exhibition these days, at Milan or wherever, and where the top design is put on show for people to know what the king's tastes were, and to sort of sell French furniture taste. So the idea is this building will become an exhibition of French furniture and art de vivre. It's the Commission des Monuments Nationaux is the client. They take care of the main most of the big monuments in France. And we were asked by Christophe Bottineau, who is the architect in charge of the Monument Historique, to help him design a skylight for the entrance courtyard. So the entrance courtyard inside this little blue rectangle was quite a dingy courtyard and not very much light. And so our challenge for this project, in Miami it was wind and sun, in this one it's light, is how we bring light into this courtyard and to be able to transform it in a similar way that the pyramid does in the Louvre, how you transform this hall into being, this courtyard into being a grand entrance hall. You can see the upper floors were later, they were added later in the 19th century and not as noble a design as the sort of pink colored ones up here. They were in the later on, added later on, not as noble. So Christophe Bottineau, the architect, said, can we make the roof at the level of the cornice? And now the later slides will show that. And these photographs of the interior of the Hôtel de la Marine, the absolutely incredible artwork on the walls, the beautiful designs, and notably the chandeliers. Chandeliers, as Christophe was telling me, was that you take the light of a candle, even for royalty, the candles were rare, and so the idea with the skylights with the chandeliers was to scatter the light around the rooms. So this is the section. of showing how we positioned the skylight at the cornice level to hide the upper floors. But you'll see here, these grey panels here, they're actually mirrors. So what we decided to do is use the upper floors as a support for mirrors, and that the structure itself is used to reflect and bounce light down inside. And Christophe he said, you know, the Parthenon is a wonderful roof with a big hole in the middle. So he inspired me to think of that maybe the roof can be like a pyramid opening, where the opening portions are just open to the sky and let the lights in. And then we can see, just in thinking about the project, wandering around, even in the metro, just reflected light sometimes can just transform a space, animating it, bringing energy, bringing light, and bringing joy. And so this was our idea. Inspired obviously also by jewelry, how jewelry reflects light and scatters the rays of light around. And this diagram of how we did it. So the red lines on the upper floors are mirrors. All of the structure is clad in mirrored stainless steel, and that is to grab as much light as we could and bounce it down inside the space. Here's the detail of the mirrors and the shape of the structure, which is fixed to a perimeter frame, which is then positioned on top of the cornice with anchors going into the walls of the existing building. And we did these desktop simulations ourselves of how the light would be bounced around inside. This is the idea of this kind of glazing framing that we used. On the right is a picture, another project I've done, where if I clad the member of supporting glass in the roof with mirror and a sharp V, I'm just going to reflect the sky on either side, and it's largely going to disappear. So in this project, I had big beams going left to right, and up and down is a mirror-clad beam. So this was convincing me and convincing the client that this was the right approach to do. And on the left is the plan showing the geometry like a jewel of the fragmentation of the glass. And then how we support the roof in 4 different triangular sections lifted up by a series of props on cables to get this feeling of the roof opening to the sky. Now this is a little simulation showing on the right the daylight you get in the courtyard before the roof, and on the right, and on the left is the light you get scattered around by the mirrors. So this composition of the mirrors on the upper floor and on our structure reflects and bounces the light around inside. And this was a perspective we did at the time to convince the client to show what we were going to achieve. And you can see how we, by making the structure much denser around the perimeter, we also mask the upper floors. So the upper floors, you don't see them. They're not in your consciousness anymore when you're beneath. These ones, the upper floors that were added later on. And then some other pictures of our drawings. Glass, we did a lot of work on the glass, reflective surfaces, acid etching to get the right levels of reflectivity using low iron glass. Drawings, more drawings, as again I said at La Villette in the beginning, are so important. The drawings tell the story of the piece of work. And I'll just flick through these quickly. And these are the contractor's drawings. Eiffage Metal, who won the contract. Curiously, they're the same people with whom I worked to do the greenhouses at La Villette about 30 odd years ago. And some photographs. A view from above. These beautiful photographs by Michel Denancé, showing how the skylight opens, and then the same view from beneath, showing how the mullions, the roof framing just literally disappears and become like a cut diamond, and you get this idea of the opening in the middle and the fanning out of the light. And then this picture was taken in January, 15th of January, and you can see daylight, sparkling daylight on the floor of the entrance hall. And then some other views of how the light bounces around in this reflective frosted glass we've got which he consciously did to kind of break out the hard sort of kaleidoscope effect that the mirrors would give. So it's a mixture of the mirror and these translucent blades beneath, and then what we hope to see for the lighting in the night. And this is it's a time lapse picture that Michel Delancey took to show how the light bounces around and reflects. You can see the reflectivity. You can see the way the crane moves above. That shows the light effect on how we've animated the courtyard with the light. So a very last quick one. This is in Wuhan, in China, where the pandemic began. We have the good fortune of working with Sino-Ocean developer, building this commercial development in the heart of the city next to an old temple. And it's really, these people are keeping me very busy these days. The city is looking forward. They want to put this horror story behind. And so it's, for me, looking at nature, being optimistic about the future. I'll just go quickly through this because it's already late. But we've been asked to do a series of clouds structures, very similar to Miami, in this development. It's right next, as I said, to the temple in the old heart of Wuhan, which is a massive city. It's where iron was first worked in China. A very, very long history. And so the idea was to grab the breeze, just like Miami, and to create natural air flow in the streets. Again, we work with RWDI, and these, like in Miami, the canopies, they become sculptures, they become iconic pieces that give an identity and a particularity to the place, but also tell the story about sustainable design. And you can see here, these are RWDI's initial studies showing how the place can get intolerably hot in the summer, and that how if we grab this on the left, all the red is intolerably hot, and on the right is the breezes. Now, the breezes in the case of Wuhan were from the south west in the summer. So we want to grab those breezes, and we decided to make the canopies then these giant scoops that go up and grab the high level breeze and bring it down into the to sort of give a feeling of air movement. Because when even if it's very hot, just the feeling of movement on your skin gives a sense of well-being and comfort. So here are some of the images of the structures that we've designed that are now being built. They're in the prototype stage. Here I'm using PTFE fabric stretched onto steel structures, and we're introducing fans because they will help move the air, but they're also visually and they're also symbolic that, you know, we're doing something, we're helping to move the air. I'll flick through quickly these. These are the studies we've done of catching the rainwater, determining doing form finding to get the right shape for the fabric, and then we put the steel that supports the ring that supports the fabric just at a slightly different plane above the fabric plane to make sure that they don't touch each other, but they're still stretching it. And then we're designing the structure, looking at where the supports are to have primary petals, secondary petals, to create, so the structure also becomes a sculptural design element, but a sculptural design element that has a functional structural performance. And so looking at the primary ones are slightly more loaded than the secondary ones. The secondary ones help the ring beam, and it becomes a pattern, it becomes a drawing, it becomes gives a specific identity to the design. And then here are some views in the streets that in the daytime you get the sun projecting the pattern of the structure above on the fabric, but then in the evening it's just there as a ghost above. So it's a very calm, luminous subject. And then the fans, which are part of the design, brings me back to designing the nuts and the bolts again. So there we are. some projects that explore engineering, architecture, and trying to learn from nature and do what we can to make the world a better place by looking at nature. So thank you very much. I hope I haven't been too long and that there's some time for questions.
Thank you very much indeed, Hugh. Fascinating to see what you've been doing, and as a continuation of Peter Rice's work as both a holistic designer, but also very much integrating architecture and engineering with the climate and nature. Absolutely fascinating. I've got a quick question. Where do you now see your work taking you, particularly considering the climate emergency? And I'm thinking now because you've been involved essentially on specific elements within projects. Do you see yourself now going for total architecture engineering within a project brief?
Well, it's business, I guess. Where you know who ends up asking you to do different projects. And it's interesting. I think the market will lead me to keep doing things like Miami, like Wuhan. And a lot of work in Paris as well with you know what you can do to give new life, which is again another sustainability to historical monuments. So and I enjoy doing that. So I don't mind. But the competition in Jamaica was the total building, and so yes, that was an experience of looking at a total building and was fun. And you can yes indeed apply the same concepts to the whole building.
Thank you. I have a question here from the audience, which comes which sort of piggybacks on that. How do you see your style of architecture evolving to suit the growing climate emergency?
Well, I think that each project is different. I can think that. Where I can see it evolving is using more and more. It's interesting. The work we've done in-house with our open source Grasshopper applications, actually working with RWDI is really quite interesting. The RWDI, I'm sure you know, is a wind laboratory in Guelph, Ontario, and they specialize in they've done most of the wind tunnel studies for structures, and they're looking now at comfort. And I think that the big potential is that technology, that ability to simulate the performance of a building in the climate, where the computer will allow us to manage massive amounts of information and the complexity of weather patterns. If we can apply that know-how in the design at an early stage, it's really quite important. At an early stage, we're very lucky to be able to have a client like Swire, to whom I said, "Yeah, Steve, can we go and play in a wind tunnel in Canada?" To have a client say, "Yes, yeah, do that," because we can see the interest in how you can apply that technology to making design better. So that's something I really would like to see develop. For a small office like ourselves, with my bright young team who explore and look and see what's on the internet and what they can find to simulate things, but to do that at a level of people with the resources with big computers and the ability to simulate the climate, I think that's where there's a big future. So I hope I've answered the question.
I think you have very well. I have another question here, Julian Lynham. What new non-traditional materials are you exploring these days?
I think photovoltaics is something. It's very interesting. We wanted to have our fans in. We did. We used fans also on the project in Sanya, the footbridge. We have is if we can use photovoltaics on the fabric surfaces. I know some of them exist, but I think that that is really very, very interesting to see how photovoltaics, which can capture the sun's energy, um, can bring us a lot of advantages. And I think there's some new developments of solar cells where you don't look like these sort of blue squares. I think that whole aesthetic of it limits you a lot. I think in the design, and I think there's a company in Switzerland that's developing a coating that was porous to UV light, but not to visual light. So this coating, you could hide the photovoltaics. So I think that's something that's quite interesting is to look at, is the technology of photovoltaics, how you can make it more palatable visually, but also the performance, because that is something that's crying out. Another thing we've been looking at, which is quite interesting, is solar air cooling, solar air conditioning, and this is a technology that exists, where you collect heat with solar collectors, and then you have converters that then convert the heat into cools. There was a guy actually, I forget his name, who did it in the exhibition here in Paris in the 19th century. He actually made ice from snow from the sun. So that's a technology that's really interesting, because then you could just imagine wherever it's hot, you get cold, immediately. That's something that'd be really cool, and I'd love to see develop.
Yes, I saw that as well. Fascinating. I'll leave one of these just for the end, but there's a question here from Stephen Lehane. Do you prefer to design with a pen compared with various software? And I know that you use all the most up-to-date software, but do you still use pen, ink, and paper for your design?
Absolutely. I think drawing, that when you draw the hands, the sketches, whether they're the sketches or the detailed drawings, it's a process where I don't use the computers myself. I use it to do Excel charts and write letters and things and write emails. But it's the young guys it's a whole different, it's a generational thing. They're completely, totally numerically literate, and could barely draw. And I think that's a tragedy. Drawing and models. Models is the other thing. Building models. And there again, we have 3D printers, which is, it's not the same as building things in 3D, but the actual business of using your hands to make things, to draw things, for me, is absolutely essential. Because you can sketch light, you can reflect, you draw shadows, you give a place life by drawing, and that's something that the immediacy of a sketch, what it symbolically, you're putting down on paper a thought instantly. Whereas the computer, you have to get the software, and it's not the same for me. So no, yes, I will still always use a pen and paper, but we still need the computers and the wonderful things you can do with them.
We have very little time left, and I still want a last question. But Pat Dallard has said many of the guys at RFL were dual qualified architects, engineers. Would you have liked dual qualification, or does the separation of architecture and engineer, the dreams and desires and warriors, help your work?
My friend Pat. Hello, Pat. I know Pat very well. Pat helped me a lot. Just after Peter died, we worked a lot together. So I know Pat, and I know he knows me. I cannot be an engineer. I'm not an engineer. Engineer is an engineer. They have a different way of thinking, or you have a different way of thinking. And I think we can understand engineering as an architect, but I wouldn't try to pretend to have a dual qualification. I've had the honor of becoming a fellow of the Institute of Civil Engineers in England, and that was a real honor for me. It allowed to tell me some of my engineer friends, look, I'm an engineer too. Sometimes you need that to muscle in an argument. But fundamentally, it's a different way of thinking. One is an analytical way, and the other one is Henry was the pessimist, I was the optimist. And so I think that's. I hope I've answered that question for you, Pat.
I hope we're not all, us engineers are not all considered pessimists, but there we are. I understand.
No. Absolutely not. No, you know what I mean? There's the business of asking questions that the architects are projecting an idea, and Peter said this himself. It's projecting an idea, and somebody's saying, okay, yeah, but you have to think of this, but doing that creatively, positively, is really important and total. And we did, Pat. We did lots of stuff together. It was really cool. That was not pessimistic.
last thing, Hugh. Bruce Dangsinger, can you tell us a nice Peter Rice story? And I'm thinking of what you told me as well the other day about going full circle, or coming full circle.
Oh, yeah, that was just a really sweet story. And as you say, it's a lovely way to end. And for us all to think of Peter. I had a wonderful experience of his daughter, Nemini, asked if I could take his granddaughter, Sophia, for a week in the studio, so she could see whether she was going to become an architect or an engineer or both, and or one or the other. And Sophia came to the office and she spent a week with us. Completely, the team took her in, and it was wonderful to have her. She looked just like Peter, and it was really spooky in a way. But she wrote me this thank you note at the end, which was to say, thank you, in a really beautiful handwriting. Thank you. I think I know my grandfather a bit better. And so that was really very touching for me.